lesson we are going to learn how to find percentage of gravel, sand, silt and clay according to the MIT system. So the question we have been given is the particle size distribution of a soil are given below. The particle size has been given and percent finer than the particle size is given in the other column. As we know from the MIT soil classification system, the particle size of gravel is measured above 2 mm. Particle size of sand is measured from 2 mm to 0.06 mm. Particle size of silt is measured from 0.06 mm to 0.02002 mm, and particle size of clay is less than 0.002 mm or 2 micron. So the first step we are going to do is that we draw the particle size distribution curve of the given soil. The particle size distribution curve of the soil is drawn by plotting the particle size on horizontal axis on log scale and percent finer on vertical axis on natural scale. So the particle size distribution curve of the soil is drawn in Excel. Particle size is drawn on horizontal axis on log scale and percent finer is drawn on vertical axis on natural scale. So the particle size distribution, we can see the particle size distribution of curve is shown here. Now for the sand we need the particle size of 0.06 mm. As we can see that there is no particle size of 0.06 mm. In fact the closest we have is 0.075 mm or 0.04 mm. So we are going to determine the percent finer for 0.06 mm from the particle size distribution curve, and for that we can see that the particle size of 0.1 mm is present here. This represents 0.09 mm, 0.08 mm, 0.07 mm and 0.06 mm. Now to determine the percent finer than 0.06 mm, we draw a vertical line from 0.06 mm which intersects the gradation curve at some point, and from that point we draw a perpendicular line intersecting the percent finer or the vertical axis. As we can see that the horizontal line intersects the vertical axis at 60%, which means that percent finer than 0.06 mm is 60%. Now as we have determined the percent finer for 0.06 mm, we can now find the percentage of various soil types. So as we know that the gravel size is measured above 2 mm, but in the given soil there is no particle size of 2 mm present. In fact the highest particle size that is present in the given soil is 0.85 mm. So it means that the gravel percentage in the given soil is equal to 0. Also the sand percentage that is measured from 2 mm to 0.06 mm, but the largest particle size in the soil that we have is 0.850 mm. So the sand percentage will be measured from 0.85 mm to 0.06 mm. For particle size of 0.85 mm, percent finer we have is equal to 100%. It means all the soil passes through 0.85 mm sieve, and for particle size of 0.06 mm, percent finer is equal to 60% as determined from particle size distribution curve. It means as the sand percentage will lie between these two particle size from 0.85 mm to 0.06 mm, it means the sand percentage in the given soil is 100% minus 60% is equal to 40%. So the sand percentage in the given soil is 40%. Now for the silt percentage, we know that the silt is measured from 0.06 mm to 0.002 mm in MIT system, and for particle size of 0.06 mm, percent finer we got is 60%, and for particle size of 0.002 mm, percent finer we got is 23%. So the silt percentage in the given soil is 60 minus 23 is equal to 37%. Now For the clay, as we know that the particle size of clay is less than 2 micron or 0.002 mm. As we know that percentage finer for 0.002 mm in the given soil is 23%, it means the clay percentage in the given soil is 23%. So the breakthrough of the given soil is that we have gravel 0%, sand 40%, silt 37%, and clay is 23%. This represents the proportion of various soil types in the given soil according to the MIT system. Hope you guys liked the video, and if you liked the video, please subscribe to my channel for more or answers to the important questions in the civil engineering. I will be posting more answers. Thank you so much, and please do subscribe the channel.